Yes, thank you, everyone. So thanks for having me here. I'm really excited to be here. And Lori, you leave big shoes to fill, not only stepping into the role of Director for Planetary Science, but also after that presentation. But it's also been fun, for Lori and I to kind of work in parallel here, figuring out the new roles and the transitions that we're both going through and kind of seeing that we're both drinking from the fire hose at the same time. So let's go to the next slide, please. And there have been shuffles and changes, at the top level in the Planetary Science Division. So let's just go through it so that they become familiar faces for you all. Now, as you've said, and as I've been able to interact with the students during the networking lunch, my name is Gina DiBraccio, and I stepped into this acting role as the director of the Planetary Science Division about 2 months ago. So my deputy remains as Eric Jansen. He's been in the role for quite a while, so might be a familiar face to you all. And not only is he the deputy of the division, but he wears several hats. He's also the director for the Mars Exploration Program, and he's the director for our radioisotope power systems. Now, his deputy in the Mars Exploration Program is Tiffany Morgan. And then if you go up to the right, Shannon Fitzpatrick, she's our new Associate Director for Flight Programs. So Shannon has several weeks more than me on the job, but she has extensive experience at headquarters. She's been at the SMD level for quite some time now. Her deputy is Christy Layton. And then if you go up to the RNA programs, now we have Kathleen Vanderkaden, who's currently the Director of Research Programs, while Stephen Reinhardt is away on detail. But for the first 6 months of Stephen's detail, we had Delia Santiago Mataris as the acting director. So after 6 months, Delia and Kathleen swapped roles there, and they're both doing a wonderful job in these positions. And then continuing over for our Planetary Defense Coordination Office, we have Kelly Fast as the Planetary Defense Officer. She's an acting role, while Lindley Johnson is moving towards phased retirement in his emeritus role as well. So let's go to the next chart. Excuse me. All right, so you've probably seen this before. It's our beautiful planetary fleet chart. We have nearly 40 missions on this chart, and it's really fun to just look at all of the diversity that we have across the portfolio. So the inner swirl that you see here, that is our Moon and Mars line. I'm sure you're very, very familiar with at least a portion of that there. And then the outer swirl is everywhere else in the solar system. And we have our missions being color coordinated by the different phases that they are in, whether that's implementation or operations, extended operations. And so if you look here, with the outer solar system swirl, we have in orange Dragonfly, Europa Clipper, and Neo Surveyor. Those are our 3 confirmed missions.
The only thing that we have that's been kind of modified is that
really
big
excited to see those missions kind of as they're moving along towards the finish line. And everything in this portfolio spans the entire solar system. So we have contributions on Bepi Colombo, which is currently on its way to Mercury, all the way out to New Horizons in the Kuiper Belt as well. Next chart. And I'll run through just a few of these missions and give you some of the highlights for you. So Dragonfly, back in November of 2023, the agency did a review of Dragonfly, but decided to postpone the formal confirmation of the mission until the FY25 President's budget request was released. When that was released, Dragonfly was confirmed on April 16th of this year. So the mission shifted into Phase C. It's now in Phase C, and it's working towards a launch readiness date of July of 2028. So right now, they're working towards their mission critical design review, which will be held in April of 25, and also the subsystem CDRs are ongoing from now until then. The launch vehicle procurement is underway, and the selection is on schedule for fall of this year. And in fact, we were just out at APL yesterday, getting to meet with the Dragonfly team, getting to see the Titan chamber where they will be doing some tests on the spacecraft itself. And it was just really fun to kind of, see everything in the works and see and meet the people who are making this become a reality. Let's go to the next chart. Okay, you might remember asteroid autumn and everything that was going on last year. And let's just talk about Lucy and Psyche. We'll get into OREX on the next slide. But here, first of all, Lucy, so launched in 2021, had a flyby of Dinkinesh just last November. And this just serves as a perfect example of all of the surprises that we have every time we encounter an asteroid, right? So we're approaching we're approaching Dinkinesh, and what we find is that it's actually a binary system. And as we keep going closer and getting these images back, suddenly we see not only is it this binary system, but the moonlet is a contact binary itself. And so there's just so many surprises already that we've had with our asteroids. But as Lucy moves on, it will have an Earth gravity assist December of this year, continue on to Donald Johanson, main belt asteroid in 2025, and then we'll finally start the tour of the Trojans in 2027. So we're looking forward to everything that Lucy discovers along the way as it's heading towards the Trojans. Now, Psyche launched in October of last year, and I have a vivid memory of this specifically because the launch was so close to the annular eclipse occurring as well. I was actually supporting the NASA broadcast for the annular eclipse, and I remember that half of the broadcast team was supporting the Psyche launch when the other half was out in Texas for the annular eclipse, and so it was really fun to just have all of these space activities going on at once so close to each other. So as far as Psyche is concerned, it has a Mars gravity assist in May of 2026, and it will arrive at Psyche, the asteroid Psyche, in August of 2029. Now, the interesting thing about Psyche itself is the fact that we have the ability to explore this metal asteroid. So something that's not made of rock, not made of ice, the first time that we can explore a body like this up close and personal, and I'm sure that we're going to have some fabulous results coming through for that too. Next slide. All right, speaking of fabulous results, you might have seen some of the first results coming out from OSIRIS-REx with the Bennu samples. The first thing that I want to do is give a shout out to our curation team at the Johnson Space Center, who has worked really hard to get the sample catalog up and running, ready to go. And so we have the link up there. You can go to that link to submit a request for samples, to work with the samples, and we have requests coming in. We have people analyzing them, good results coming out. Now, from these first results, there was a series of exciting information that was published in the first paper in MAPS, but I know that there's a lot of more exciting results that will come from this as well. So what the team found in this initial result is that really Bennu is showing that we have these key components, these key ingredients that are basically the ingredients that form the solar system and represent life as we know it today. And that means they've observed carbon and nitrogen and organic compounds. We also found that the samples really are made of a clay material that is representative of mid-ocean ridges that are here on Earth. And that clay material suggests that it's a water-rock interaction. But what was really exciting from these results, what the team is really most excited to get out there to the public and the community, is the fact that something that they didn't observe during their remote sensing observations prior to the sample return is the fact that there's an abundance of magnesium sodium phosphates. So this was not something that they were necessarily expecting in this abundance because it wasn't detected from the remote sensing. And so it's leading to suggestions about the wet past of Bennu and its origins, and we really look forward to the team's upcoming results to really understand some more of the origins of Bennu and some asteroids like this as well. Next chart. Okay, let's talk about the lunar samples from Chang'e 5. So the Chinese Space Agency opened applications to access these lunar samples at the international platform back in 2023. Then in November, Administrator Nelson certified to Congress that there was the NASA intent to allow NASA-funded researchers to apply for access to these samples. And this would be a limited exemption to the Wolf Amendment. Now, we released an NSPIRES notification in November, and this was amplified by League and also by XMAG. And so with NASA, we're really continuing to coordinate with these US researchers that did apply for these lunar samples. And we're aware that they were interviewed by the Chinese National Space Agency, so we've been in the loop closely with our researchers on this. Now, we understand that there's a second opportunity for international proposers to access Chang'e 5 samples later this summer. And basically, we're aware of the community interest. We're excited to see how this first round goes, and we'll wait to see what the future is based on how the first round of accessing these litter samples go as we work with our Chinese partners. Next slide. Okay, so for Europa Clipper, this spacecraft was delivered to Kennedy back in May of this year, so just a couple of months ago. The launch window opens in October 10th to be exact. We're starting the official countdown here, and as long as everything goes well for October, we are expecting a Jupiter orbiter insertion of April 2030. Now that the spacecraft is at Kennedy, it's going through ATLO, assembly, test, and launch operations. We have the environmental testing complete. We're going through the different systems testings that are all part of ATLO. And we, as I said, successfully shipped all the way from JPL to KSC. So we're looking to really analyze that final launch software, how it's delivered, and the solar arrays will be installed later this summer. And so, of course, I'm sure in the news and in some of the press you've seen recently about the MOSFETs on Clipper, and I'll just address that by saying right now our team at JPL is working really hard to test these transistors that are on the spacecraft. They essentially regulate and gate the flow of electric currents throughout the spacecraft. And what we found through non-NASA customers on different missions was that they might actually not be able to withstand the radiation tolerance that they were first designed to meet. And so our JPL team is working really hard to see if that's actually the case, to test, what we know about the parts and to come up with a good solution, both operationally and how these parts, just understanding how the parts will operate at Jupiter in that high radiation environment. And so we're looking forward to the analysis. We don't have the results of that yet, but we have continual check-ins with the team just to see how great the progress is going on that. Next chart. Okay, and I know that we had a lot of discussions about Viper, but as Lori said, I'll make a nod to it here as well. The Viper team has been working extremely hard, and that is completely recognized. And of course, this was not an easy decision to be made by the agency. I was listening in yesterday when Joel did his question and answer session with you all, and hopefully he was able to address many of the questions you have. If you have more questions, I'm happy to attempt to answer them or get in contact with Joel to get you those answers. But I also did want to outline just how Viper and kind of the LDEP portfolio falls within planetary. And so as I said, the information by Joel was shared yesterday, but as far as the Viper budget, that sits within the Lunar Discovery and Exploration line, that's LDEP, and that line does sit within the Planetary Science Division budget. However, it is managed by Joel out of the SEO office. So the implications of the cancellation for Viper are contained within that LDEP budget line, which is why when Joel was addressing your questions, he was talking about the future of CLIPS and, had Viper not been canceled, any impacts that it would have on future CLIPS missions and landings. But really discontinuing the development of Viper is enabling these resources within that LDEP line to be focused on these CLIPS deliveries and other future opportunities that we have. But as you've been hearing, I'm sure, overall, our planetary science budget and the Science Mission Directorate budget in general is extremely constrained in FY24 and 25. That's part of the Fiscal Responsibility Act, and, we are pushing to do as much as we can within that constrained budget. And just to put some numbers behind the words that I'm saying, you can see at the table at the bottom here, this is the planetary science budget over the last decade. So you can see how it's evolved over the last 10 years. These are real year dollars that you're seeing here. And essentially, where we were a decade ago is quite different from where we are today. So even though it's tight times, just looking at our progress is really a nice thing to reflect on. Now, if you consider from FY23 to 24, that's when that Fiscal Responsibility Act went into play, and that's when we started taking those budget cuts and those hits that we're really trying to juggle across our portfolio as best as we can. Next chart. Okay, so let's celebrate success while we're at it. Next chart. The first thing that I'm really excited to talk to you about are the award winners of our 2023 Planetary Science Division Early Career Awards. Now, these PIs were selected for the fact that they had these great proposals that really showed promise to making impacts on the community, and they demonstrated their potential leadership ability in the field of planetary science for years to come. So just so you know, these awards can be up to $200,000 as well for each PI. So we are really hoping and have a lot of inspiration and motivation from these individuals that they're going to have a big impact on the community. So first we have Emily Costello out at Hawaii, and her project, she proposed to work on navigating by moonlight, the art of planetary science. Now with this project, what she'll be doing is actually combining planetary science with local art that's indigenous to these Hawaiian cultures that she's surrounded by, and really spreading out planetary science throughout Hawaii there. Chris Fowler at West Virginia University is working to bring planetary science to West Virginia. And so their planetary science program at West Virginia University is growing as we speak. And as part of this program, Chris is also planning to engage high school students from underrepresented areas around West Virginia. Then we have Peter James at Baylor University, his proposal on origins of porosity on rocky planetary surfaces. As part of this, he will actually be creating a crater boot camp with undergraduates out in the Texas area so that we can really work on understanding the knowledge of rocky planets throughout undergrads in that area. Then we have Kelly Miller at Southwest Research Institute. Her project on carbon-based connections from Earth to the outer solar system will be focusing on a lot of engagement with middle schoolers as well. And then finally, Laura Rodriguez at LPI, supporting planetary science and mission work with astrobiology spectral database. And that's creating a database so that we can make the data more accessible to the community, so that people can access it and really kind of push the science return of some of the data that we have here. Next slide. Our Here to Observe program. So I'm excited to announce, you might have heard about this in the past, we've added new teams. So Here to Observe is a really great way for undergrad students at underrepresented universities to become a part of our missions, to really engage and become a part of planetary science earlier in the pipeline than they might have without this program. And the way that it works is the student works with a faculty advisor at the university and pairs up with a liaison from one of our missions so that they can engage with the team from the start and hopefully, continue down the path of becoming planetary scientists throughout their career. So you can see all of the missions that we have participating in this. The two on the right are the newest ones. So we now have Perseverance paired with Kutztown University, and we have Neo Surveyor paired with California State University Channel Islands. And so they've been added to the list. But we are slowly rolling out this program intentionally to make sure that it's done the right way, to make sure that any lessons learned can be applied before growing the program too big. And I will also say that this is a no due date opportunity in Roses as well. So you can propose to this as an undergrad student at any time. Next chart. Okay, let's talk about the moon's moment in the sun. So there was a wise woman that said you can't have an eclipse without the moon, and that wise woman was Lori, and it's true, right? So I was able to be a part of the broadcast for the total solar eclipse, and the one thing that I really want to give a shout out to is the survey team really supporting the live feed. We have that shown up on the left-hand side in Mazatlan, Mexico. That was, were you there? Yeah, you were. That was the first, view that we had of the eclipse on the broadcast, and that was just wonderful. I remember kind of watching it and hearing everybody talk about it and getting excited because we got to see the eclipse start and then move all the way across the U.S. So as far as NASA is concerned, we had many engagements. Across that path of totality, there were 12 what we call sunspots, which is really just those epicenters of really bringing the community together so that we could celebrate the eclipse, and both planetary science science and heliophysics played a really big role in this. So just a shout out to everybody that was involved here. I can't help but laugh every time I see this social media post on the upper right where NASA Moon blocked NASA Sun. So that was one of my favorites. But yeah, as far as the broadcast is concerned, the last we checked, there were at least about 40 million views on the broadcast, which is huge. It's huge. So there was a lot of public interest around the world, and that number only includes the NASA views that we can count. That doesn't include other networks that were streaming that broadcast for us as well. Next chart. Okay, and I know that you all are experts on this, and I don't need to say it, but it is an exciting time for everything going on at the moon. So back in February, we had Intuitive's machines successful soft landing, the first successful soft landing of a U.S. entity on the moon since 1972. So that is something to really be celebrated here. And then we have a lot to look forward to coming up, especially the attempted landings that will come up later this year with Firefly's Blue Ghost Mission 1 carrying 10 of our payloads on board. And then, of course, the IM-2 launch later this year as well, where we have Lunar Trailblazer that will be on board of that as well. And so Lunar Trailblazer, part of our Simplex program, that's a small, low-cost mission that's going to explore water on the moon, the form, the abundance, the distribution, and we're excited to see all of the results from this as well. Next chart. All right, and that wraps it up for our planetary science overview. Thank you.